Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain about Chemistry Higher Level Paper 2, November 2021. If you find this video is helpful, please don't forget to subscribe and let your other friend knows about my channel to support me. And now let's get started. A 4.406 gram sample of a compound containing only C, H, and O was burned in excess oxygen. 8.802 gram of CO2 and 3.604 gram of H2O were produced. Determine the empirical formula of the compound. So first, we need to find the mass of carbon and hydrogen, and we can calculate the mass of oxygen, and then we can check the ratio to find the empirical formula. So mass of carbon, that would be 8.802 times 12 divided by 44. 12 is the relative atomic mass of carbon and 44 for CO2. You will get 2.402 gram, and for hydrogen 3.604 from here, but it should be 2 times 1.01 divided by 18.02. So 2, because of hydrogen in H2O, there are 2 hydrogen. So the relative atomic mass of hydrogen, and this is for H2O, you will get 0.404. Okay, so if you add this 2, that would be 2.402. Therefore, you can calculate mass of oxygen, which is 4.406 minus 2.402 is 1.6 gram. So mass of oxygen only, that would be 1.6 divided by 6 relative atomic mass of oxygen, which is 0.1. So if we do the number of mole for each of this, so mole of C, that would be 2.402 divided by 12, which is 0.2. And for hydrogen, that would be 0.404, this one, divided by 1.01, that would be 0.4. And for oxygen, that would be 1.6 gram, yeah. So divided by 16, 0.1. So as you can see, this 2, 4, and 1. Therefore, the empirical formula would be C2H4O. Determine the molecular formula of this compound of its smaller mass, 18.12. So MR of our empirical formula, which is C2H4O, it's 44.06. So if we want to determine the molecular formula, we need to divide first the molar mass divided by molecular formula of the empirical formula, which is 44.06, and we get the ratio is 2. So the molecular formula of this compound would be 2 times C2H4O, so C4H8O2. The following spectrum show the infrared spectra propanol, and propanoic acid. So that would be this one. So as you can see in the spectrum, there is 3000 right here. So it's propanol. So for propanol, that would be OH. So it's 3000 to 3600. So OH 3000 to 2200 to 3600. And the second one is propanol. So propanol, it has also OH. Okay, so then that's the case. It's not for OH, it's for what do we have more? Propanoic acid, because it has OH. So this in the range 2500 to 3000 OH. And then for this one, it's carbonyl, which is 1700 to 1750. So this will be C double bond O. Why? This is 2500 and this one OH until 3600 is available in data booklet. For alcohol is 3200 3600, and for carboxylic acid is 2500 to 3000, and for C double bond O in the carbonyl molecule, so 1700 to 1750. So here is not really sharp down here, so there is no OH. That would be propanol, and it has C double bond O. Okay, now let's check the question. Identify each compound from the spectra given. Use absorptions from the range of 1700 to 3500. So the first one will be propan 1-ol. The reason presence of OH in alcohol, peak in 3200 to 3600 centimeter to the power -1. The second one is propanoic acid. So there is carbonyl C double bond O, and OH in carboxylic acid, peak in 2500 to 3000 and 1700 to 1750. And the third one, it's propanol. Presence of carbonyl C double bond O, peak in 1700 to 1750 centimeter to the power -1. Predict the number, HNMR signal, and splitting pattern of this CH3 scene for propanol and propanol. Okay, so let's do propanol here. C double bond O, CH3, and the other one is propanol. So CH3, CH2, C double bond, and then H. As you can see, this is symmetrical. So CH3 here and CH3 here, they have the same kind of H environment. So the number of signal will be only 1. And for propanol, these are the same, different. This also different, and this also different. So it will be 3. And splitting pattern of CH3. So for CH3 here, or this CH3 is next to the C that doesn't have H. It means splitting pattern will be singlet. But CH3 here is next to the CH2. So it would be triplet. So if it's next to the C that doesn't have H, it will be singlet. If it's next to the, for example, CH2 here, next to the H, and then 1 and then 3, so that will be multiple, because you guys just learned until quadruplet. And if it's next to no C, that will be no H, next to the C that has no H, that will be singlet. Next to the CH, that will be doublet. Next to the CH2, that will be triplet, and then next to the CH3, that will be quadruplet. Okay. Electron transitions are related to trends in the periodic table. Explain the general increase in trend and the first ionization energies of the period 3 elements in A2AR. So increases number of proton, atomic radius, size decreases, because in A2 AR, the same period. So number of proton increases, the atomic number increases. So the attraction, as you go across the period, the number of protons in the nucleus increases, increasing the attraction between the nucleus and the valence electron. The number of electrons also increases, but as these electrons are on the same shell, or the valence electrons are the same, they do not increase shielding. As a result, the first ionization will increase. Sodium emit yellow light with a frequency 5.09 times 10 to the power 14 Hertz when electrons transition from 3p to 3s orbital. Calculate the energy difference. So delta E will be H times V. So H from the data booklet, section 1, Planck constant, which is 6.63 times 10 to the power negative 34 joule second times frequency is provided 5.09 times 10 to the power 14 s to the power negative 1, which is 3.37 times 10 to the power negative 619 joule. White phosphorus is an allotrope of phosphorus and exists as P4. Sketch the Lewis electron dot structure of the P4. Okay, that would be like a pyramidal structure. That would be like this. I will just make it so like this, P and then P. Okay, so it has a lone pair for every single P. So 5 valence, P has 5 valence electron and 3 single bonds and 1 lone pair. Each P can form 3 single bond to each P atom, leaving a lone pair, okay, forming pyramidal structure. The diagram should each P bonded to 3 others for you to get 1 point. Write an equation for the reaction of white phosphorus with chlorine gas to form phosphorus 3 chloride. So that would be P4 solid plus 6Cl2 gas forms 4PCl3 liquid. Deduce the electron domain and molecular geometry using VSEPR theory and estimate the Cl-PCl bond angle in PCl3. So PCl3, if we draw the Lewis structure, so it has 4 domain, okay, because 3 bonds and then 1 lone pair. So the electron domain geometry would be tetrahedral and molecular geometry will be trigonal pyramidal, and the bond angle will be 100 degrees. Outline the reason why PCl5 is a non-polar molecule while PCl4F is polar. PCl5 is non-polar because it's symmetrical, or the dipole moment is cancelled, because PCl5, so dipole moment is cancelled, so because it's symmetrical, okay? And what about PCl4? Alright, so the dipole moment will go towards here, but the other one will be towards here, so it's not symmetrical because F is more electron negative compared to Cl. Okay, PCl has a different bond polarity than PF, non-symmetrical dipoles. Okay, so it has different polarity. An equilibrium exists between PCl3 and PCl5. Calculate the standard enthalpy change for the forward reaction. So for Cl2, it's 0 because it's in their standard state. So delta HF will be product minus reactant. That will be negative 398.9 minus negative 306.4. You will get negative 92.5 kilojoule per mole. Calculate the entropy change, delta S in JK mole for this reaction. Also will be product minus reactant. So product will be PCl5 364.5 minus 311.7 plus 223. So that would be negative 170.2 J per K mole. The reaction was repeated at a lower temperature. Sketch label Maxwell-Boltzmann energy distribution curves at the original temperature T1 and the new lower temperature T2. Okay, so Maxwell-Boltzmann, always the first one will be like this, and the second one is a bit low. Okay, lower temperature. So as the new lower temperature will be T2, and then this will be T1 because this one is lower temperature. Higher temperature always slightly to the right. Okay, so this the higher temperature and this one the lower temperature or original temperature. This one is lower temperature. Higher temperature slightly right as more particles have more kinetic energy. So this one has higher temperature. Phosphoric acid H3PO4 can form 3 different salts depending on the extent of neutralization by sodium hydroxide. Formulate an equation for the reaction of 1 mole of phosphoric acid with 1 mole of sodium hydroxide. So phosphoric acid H3PO4 aqueous react with NaOH aqueous. If you don't know how to form the product, you can dissociate them into the ion. So this phosphate ion, and this one is Na plus and OH minus. So PO4 3 minus with Na plus because negative and then positive. So Na plus PO4 3 minus. So it will be crisscross Na3 PO4. Okay, aqueous plus H2O, H plus and OH minus. All right, so that would be 3 NaOH here and then 3 H2O here. Then it is balanced. Formulate 2 equations to show the amphiprotic nature of H2PO4. Amphiprotic means it's available to donate proton or accepting proton. So it can react as a base or acid. So first one, H2PO4 minus as a base, react with H plus, will produce H3PO4. And as an acid, react with OH minus, produce HPO4 2 minus plus H2O liquid, acting as an acid. Calculate the concentration of H3PO4 if 25 centimeter cube is completely neutralized by the addition of 28.40 centimeter cube of 0.5 NaOH. So we need to find mole of NaOH first, which is, this is the volume and this is the concentration. So let's convert this into decimeter cube times concentration. you will get 0.01420. And for H3PO4, the question, the reaction, okay, H3PO4, when it reacts with NaOH, will form Na3PO4 plus H2O, and this will be 3. If you find difficulties, you just need to dissociate it into ion. So PO4 3 minus and then H plus. And for this one, Na plus OH minus. So when this one combine, Na plus and PO4 3 minus, this one will go down and this one will go down because it's 1, so there is no coefficient. And then you balance them. H always with OH minus will form H2O. So for mole of H3PO4, the coefficient is 1. So that would be 1/3 times mole of NaOH will be 0.00473. And the concentration now we can find out, which is 0.00473 divided by volume 0.025, this one, and you get 0.1893 mole per decimeter cube. Outline the reasons that sodium hydroxide is considered a Bronsted-Lowry and loose base. Sodium hydroxide, when it dissolves in water, it will form Na plus and OH minus. Okay, Bronsted-Lowry base makes OH minus can accept proton, produce H2O. So it's proton acceptor, and Lewis base, in OH minus, it has a lone pair. So it can give or donate a pair of electron. Biochemical oxygen demand, BOD, can be determined by the Winkler method. Outline what is measured by BOD. It's amount of oxygen used to decompose the organic matter. As students dissolve 0.1240, the uncertainty is 0.001 gram of sodium thiosulfate to make 1000, 0.4 as the uncertainty centimeter cube of solution to use in Winkler method. Determine the percentage uncertainty in the molar concentration. So percentage uncertainty in mass will be 0.0001 divided by 0.1240 times 100, 0.08%. Percentage uncertainty in V, it's 0.4 divided by 1000 times 100, it's 0.04%. Therefore, percentage uncertainty is 0.08 times plus 0.04, it's 0.1%. Okay? A 25 centimeter cube sample of water was treated according to the Winkler method. These are the reactions, and the iodine produced was titrated with 37.50 centimeter cube of 5 times 10 to the power negative 4 sodium thiosulfate. Calculate the amount in moles of Na2S2O3 used in the titration. So mole will be C times V, which is 5 times 10 to the power negative 4 times 0.0375 divided by 1000. Produce 1.875 times 10 to the power negative 5 mole. Reduce the mole ratio of O2 consumed in step 1 H2S2O3 2 minus used in step 3. 1:4. How? You can see here from the reaction, oxygen reacts with Mn2 plus, 2Mn2 plus, producing MnO2. So to produce MnO2, it needs to consume oxygen. MnO2 then react with iodine ion, producing and also H plus, producing iodine that will react with sodium thiosulfate. Okay, so in step 1, each mole of oxygen produce 2 mole of MnO2 and produce I2. Okay, it reacts with 2 mole of sodium thiosulfate. So there is 2 mole right here, and then it reacts with 2 mole right here as well. That's why it will give 1:4. Calculate the concentration of dissolved oxygen in mole decimeter cube in this sample. We already find out mole of thiosulfate. And the ratio between oxygen and thiosulfate is 1:4. Therefore, mole of oxygen will be 1/4 times mole of sodium thiosulfate, which is 4.668 times 10 to the power -6. So the concentration of oxygen will be N divided by V. 4.668 times 10 to the power -6 divided by 0.025. It's 1.875 times 10 to the power -4 mole per decimeter cube. The 3 steps of the Winkler method are redox reaction. Deduce the reduction half equation for step 2. MnO2 plus 2 electron plus 4 H plus produce Mn2 plus 2 H2O. Okay, the step is half equation for step 2, as you can see here. Okay, MnO2 and Mn2 plus, that will be the half equation. MnO2 becomes Mn2 plus. Okay, here has 2 oxygen extra, but there is no oxygen right here. To make it to be equal, we can add water. And now 2 oxygens is available here and is balanced, but there is H plus right here, which is 4. And look at the charge. Here is +2 and here is +4. So to balance the charge, we can only add electron, which is negative. So we need to reduce the amount of positive right here by adding 2 electron. So now it becomes +2 and here becomes +2. That's how you get this answer. Suggest a reason that the Winkler method used to measure biochemical oxygen demand must be done at constant temperature. So rate at which bacteria grows or respire, or their respiration, depends on the temperature. Because temperature affects metabolic process within the bacteria. If it's higher, the higher temperature will increase metabolic rate. Therefore, to maintain temperature is very crucial to get accurate measurement. Alkanes undergo combustion and substitution. Determine the molar enthalpy of combustion of an alkane if 8.75 times 10 to the power -4 moles are burned, raising the temperature 20 grams of water by 57.3. So Q is mc delta T, and when we can divide it by the mole later on. So 20 times 4.18 times 57.3, which is 4,790 joule. And to find delta H is 4,790 divided by 8.75 times 10 to the power negative 4 divided by 1,000, because delta H should be in kilojoule, so we divide again 1,000 because you know Q we got here in joule, and you will get negative, this should be negative, yeah, because combustion increase in temperature, so it's negative, so it will be 5,470 kilojoule per mole. Formulate equations for the 2 propagation steps and 1 termination step in the formation of chloroethane from ethane. Propagation involves continuation of reaction by producing reactive species that can further react. It involves the formation of reactive intermediates which continue the change reaction by reacting with other reactant. So we have chloroethane, C2H5Cl, and C2H6 ethane. Okay, so propagation producing reactive intermediates that react with other reactant. So you know the first initiation, Cl2, it will produce Cl radical and Cl radical. So for propagation, it will be Cl radical react with other reactant, which is C2H6 produce C2H5 radical and HCl. And we have also chloroethane. So chloroethane, before it produce chloroethane, so chloroethane, this also becomes a radical, C2H5 as a radical, react with Cl2, because when C2H6 lose 1 electron, it becomes a radical. That's why C2H5 here, one of the reactive intermediates. So it will produce Cl radical and C2H5Cl. Okay, these are the propagation. And for termination, involves the combination of reactive intermediate. So involve the combination of reactive intermediates to form stable product. So the reactive intermediate will react with each other, forming a stable product, or the other one could be C2H5 plus C2H5 will produce C4H10, or C2H5 plus Cl radical produce C2H5Cl. The standard electrode potential of zinc can be measured using a standard hydrogen electrode. Draw and annotate the diagram to show the complete apparatus required to measure the standard electrode potential. So we will have the wire right here. Okay, so this will be voltmeter, and we should have salt bridge, and because zinc right here, so this will be solution of zinc 2 plus aqueous should be 1 molar, and this one should be acid solution containing 1 molar decimeter cube H plus, because you know the standard hydrogen electrode potential should be 0.00, so H plus plus electron produce half H2, it's 0.00, and this should be platinum electrode, and there is hydrogen gas at 298 Kelvin and 100 kilopascal. They are default at this condition. Okay, fast-moving helium nuclei He42+, were fired at a thin piece of gold foil, with most passing undeflected, but a few deviation largely from their path. The diagram illustrates this historic experiment. So, suggest what can be concluded about the gold atom from this experiment. Most of the atom is empty space. Very few helium deviating largely from their path, because nucleus is very small and dense compared to the size of the atom. The experiment with fast-moving helium nuclei fired at the thin gold foil. It showed that most of the nuclei passed through the foil undeflected. This implies that atoms are mostly empty space because of the majority space within an atom allowed the helium nuclei to pass through without interaction. The fact that only a few nuclei deviate largely from their path indicates that the nucleus or center of the atom is very small compared to the overall size of the atom. Subsequent experiments show electrons existing in energy levels occupying various orbital shapes. Draw diagram of 1s, 2s, and 2p. This will be 1s a little bit small and 2s and p. State the electron configuration of copper. Copper is 29. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. So AR 4s1, 3d10. Or if you want to write in the short notation, yeah. Copper is a transition metal that forms different colored complex. A complex CuH2O62 plus changes color when excess Cl minus is added. Cl or chloride is lower in the spectrochemical series, causing lesser splitting in d orbitals compared to H2O. So frequency or energy of light that is absorbed decreases. Okay, in this spectrochemical series, which is section 15, okay, this, okay, so Cl is lower than H2O. In the spectrochemical series, ligands are arranged based on their ability to cause splitting of d orbitals in the central metal ion. So it's based on the order from weaker to strongest. Chloride ions being lower in the series compared to H2O imply that they cause lesser splitting in d orbital. Thus, when light interacts with the complex, it is absorbed by the electrons in the d orbitals, causing a shift in the energy level. The energy of the absorbed light corresponds to the energy difference between the d split orbital. With chloride ions causing lesser splitting, the energy of light absorbed decreases. Hybridization of hydrocarbons affects their reactivity. Distinguish between a sigma and pi bond. This is sigma bond. And this is pi bond. So sigma bond is overlap along the axial or intermolecular axis between nuclei, and pi bond overlap above and below the internuclear axis or sideway overlap. Okay. Identify the hybridization of carbon in ethane, ethene, ethine. Ethane, CH, CH, H, H, H. Ethene, double bond, and ethine, triple bond. As you can see here, the C has 4 region or 4 domain. So 4 domain sp3. This one 3 domain. This C also 3 domain sp2. This one only 1. Oh, sorry, 2. 1 2 1 2 sp. State giving a reason if but1-in exhibits cis trans isomerism. But1-in will be C2H5 H H cis, because the same site. So state giving a reason if butane exhibits cis or cis trans isomerism. No, it's only cis. So no, as 2 groups on a carbon in the double bond are the same. State the type of reaction which occurs between but1-in and hydrogen iodide at room temperature. It's electrophilic addition, because but1-in H2C CHC2H5 plus HI. It's a reaction which a molecule is initially attacked by an electrophile, resulting in the addition of one or more relatively simple molecule across a multiple bond. Okay, so that will be add, and it will be double bond, this double bond break into single bond, and then add H and I here. So it's called electrophilic addition. Explain the mechanism of the reaction between but1-in with hydrogen iodide using curly arrow. But1-in with hydrogen iodide. So H will be, this is the arrow, and that will be the arrow. I will explain it later. Okay, so in this reaction, but1-in contain double bond, which has strong sigma and weak sigma bond, strong sigma bond, and weak pi bond, act as nucleophile, donating 2 pi electrons to an electrophile Hi that has a polar hydrogen iodide bond where the hydrogen atom is an electrophilic center. A pair of electrons from the carbon double bond are used, forming a new bond with the hydrogen atom. Then the hydrogen iodide bond will split heterolytically, forming iodide ion. As the pi bond is no longer exists, now becomes single bond, this allows the formation of carbocation intermediate. Iodide ion is acting as a nucleophile reacts quickly with the carbocation intermediate, producing the addition product. State giving a reason if the product of this reaction exhibits stereoisomerism. Yes, and has a carbon attached to 4 different group. So it contains a chiral carbon. As you can see here, this carbon attached to CH3, I, H, and C2H5. So attached to 4 different group. Experiments were carried out to investigate the mechanism of reaction between 2-chloropentane and aqueous sodium hydroxide. Deduce the rate expression for this reaction. For this one, to get the order of reaction of C5H11Cl, so this 1.5 and this one also 1.5. Therefore, the order of C5H11Cl is 1. And what about NaOH? Let's see the calculation. So if I take 1 and 2, first experiment and third experiment, that would be 1.00 times 10 to the power negative 1 divided by 2.5 times 10 to negative times 2 times to the power negative 2. So that would be 0.2 times 0.4, 0.2 times 0.4 divided by 0.1 times 0.2, this one. This would be 10, yeah? 10 to the power 10 times 10 to the power negative 2, that would be 4. This one, 0.08 divided by 0.02, which is also 4. So, also 1. Deduce the units of the rate constant. Okay, so the rate constant, because of the order of reaction is 2, so that will be double. Therefore, to find K, rate divided by concentration of NaOH and C5H11Cl. So that would be, let's see the unit, mole decimeter to the power negative 3 S to the power negative 1 divided by mole decimeter to the power negative 3 squared, because double. So you will produce mole to the power negative 1 decimeter cube S to the power negative 1. Determine the initial rate of reaction in experiment 4. As you can see, there is no initial rate for the experiment 4. So we need to find K first, so we can find rate. K, it's rate times the divided by the concentration. So the first one is 2.5 times 10 to the power negative 2 divided by 0.2 and 0.1. So I will just plot directly. 2.5 times 10 to the power negative 2 divided by 0.2 times 0.1. You will get 1.25 mole to the power negative 1 decimeter to the power negative 3 and S to the power negative 1. And to find rate, that would be 1.25 mole decimeter mole to the power negative 1 decimeter to the power negative 3 S to the power negative 1. And we can calculate with the concentration of NaOH and C5H11Cl, which is 0.6 and 0.25 times 0.6 mole decimeter negative 3 and 0.25 mole decimeter negative 3. This finish, this finish, this finish, this finish, you get 1.9 times 10 to the power negative 1 mole decimeter negative 3 as to the power negative 1. Deduce with a reason the mechanism of the reaction between 2-chloropentane and sodium hydroxide. It's SN2 and rate depends on both OH and 2-chloropentane. So 2-chloropentane, it's secondary halogenoalkane. CH2, so chloropentane, CH2, CH3 plus NaOH. So it's secondary. Okay, because it is a secondary halogenoalkane, thus it can undergo both SN1 or SN2. But to judge the type of reaction, whether SN1 or SN2, it is based on the nucleophile. The nucleophile here is OH minus. If it's strong nucleophile, it favors SN2. So OH minus is strong nucleophile. The other way to find whether SN1 and SN2, if the solvent is known. If the solvent is polar protic, is SN1. If it's solvent polar aprotic, is SN2. And as you know, this now is SN2, and the rate is second order of reaction, where nucleophile and halogenoalkane are affected or given effect. Therefore, it depends on both OH minus and 2-chloropentane. Discuss the reason benzene is more reactive with an electrophile than a nucleophile, because it has delocalized electron around the ring, because it is also called electron rich, where electrophile are attracted but nucleophile repel. Okay, electrophile is positively a charge, so it needs electron, and it is an electron rich, so that's why it's matched with electrophile. But nucleophile is also electron rich, that's why it will repel. So it is more reactive with electrophile or nucleophile, not nucleophile. 50 centimeter cube of 0.75 molar sodium hydroxide was added in 1 centimeter cube portion of a 22.5 centimeter cube of 0.5 molar chloroethanoic acid. So Ka will be 10 to the power negative 2.87. So you get 1.35 times 10 to the power negative 3. So Ka will be concentration of chloroethanoate and H plus divided by chloroethanoic acid, because when chloroethanoic acid with NaOH, it will form chloroethanoate, and Ka is 1.35 times 10 to the power negative 3. We don't know the concentration for this. Let's just give x squared, and we know the concentration of chloroethanoic acid, which is 0.5. Then you can find x right here, which is one of them is H plus, this multiplied by this, so 1.4, let's say 1.4 times 10 to the power negative 3 times 0.5, you get 2.6 times 10 to the power negative 2 mole per decimeter cube. Then now you can just find out the pH by this concentration, which is 1.59. The concentration of excess sodium hydroxide was 0.362 mole decimeter cube. Calculate the pH. pOH first, because this one is sodium hydroxide. That will be negative log 0.362, which is 0.441. pH will be 14 minus 0.441, which is 13.559. Sketch the neutralization curve obtained and label the equivalence point. So this will be, okay, here. It will start with 1.59. We do the calculation from the previous question, 1.59, and it stopped in 13.559. Okay, so that would be like this, and then I will just make it a bit nicer. And then like this. Okay, and the equivalent point should be bigger than 7, around here. Okay, so I take the half between this area, so this will be the equivalent point. All right, so that's all the explanation for paper 2HL, November 2021. If you find this video is helpful, please don't forget to subscribe and let your other friend knows about my channel to support me. Thank you for watching, and bye.